difference curve, like this, what should be on the y-axis and x-axis for the difference curve? Y, X, and two goods, I suppose there are only two goods available to this person. An indifference curve like this. I give you, for example, point A, point B, and point C. Which of the following is correct? A statement like that. You need to know bundle A and bundle B, that is combination. Right? If the person buy this combination of good X and Y, and this combination good and Y, because bundle A and bundle B provide the same amount of utility to this person. And the more to the northeast, the higher the utility that bundle provided. That means bundle C is preferred to bundle A or B. Okay? Bundle C, this combination of X and Y, give people higher utility than A and B or B. That's the first question. Second one, combine the indifference curve with the budget constraint to solve the utility maximization problem. So this is a indifference curve, right? And then the other term, we need to combine this with the budget constraint. And then the budget is here. This is our budget. And what a combination good and X and Y can give people the highest utility. Or if we know this is a good Y, good X, this is a budget. Budget is fixed, right? How much money can earn this month. And then there's an indifference curve. And which combination of goods X and Y can provide this person the highest utility? Okay, we need to know that combination good and Y happened on the point. We have this budget line tangent to the indifference curve. This point.
Is it going to be graphically, so not like equations?
No.
Graphically?
No. I will not show you the graph. I just give you, for example, I give you margin rate of substitution, or MUX, MUY. As Y, this is X, for example. Okay. Price of X is $2, price of Y is $4, for example. And the person has $100 available. What the optimal level of X and Y the first person will purchase to maximize the profit,
Won't they get all of X?
maximize the utility.
Would they get all of X? Since it's cheaper, they can get more units.
Okay. That's when the two goods are perfect substitutes. So in this case, there's a condition. Right? And the condition is make the slope of budget line equal to the slope of indifference curve at this point. Slope of budget line is negative P of X over P of Y. Price of X over price of Y equals slope of indifference curve. That is margin rate of substitution. Margin rate of substitution, or MU X over MU Y. Okay, just make sure that the budget line tangent to the indifference curve. So it's PX over PY, all positive, equals MUX over MUY. Okay, and in this equation, since you know the mathematical expression for margin of utility of X, margin of utility of Y, that's this PX, PY, 2 over 4, right, for example. 2 over 4 equals Y over X. Two unknown variables, but one equation. You need another one, is if we know the total income available is $100. And then you should, PX times X plus PY times Y is 100. So this one is 2, and you can solve for X and Y. X and Y are quantities, right? Quantity of X and quantity of Y. It's $2, Y is $4, 100. Right? So that's the second piece of the budget. And this is the condition we need for the utility maximization.
So we only have to know the normal goods, we don't have to know special cases.
Only the things that listed on the. So that's chapter 4. Any questions so far?